We good to go? Yes. So like, all right. So what problems did you guys have so far, right? Like, how to start? Okay, that's a big problem. Okay, so like, gets is basically reading input from like standard in, and just writing it to this buffer, right? And main has its own return address, so you just want to write enough bytes so that you corrupt the return address. Okay. So, anyone use the debugger for GDB? You. All right. Well, let's use GDB. So I think that's it. Well, yeah. Okay. So GDB. That right? R is run. So I just send it like a bunch of A's, right? I think that's enough. And boom. It has 6 right? And 4141 is my A in hex, right? So what happened was when it tried to return, it's trying to return to this A, right? So how do we know, like, can you see anything? It's pretty bad. So like, over here, it's saying invalid program counter address, right? 414141. That's my A's in hex. It's trying to return to my A's, and that's not a valid address. So one of the problems, I guess, was how do I know how many A's do I need to send, and the next 4 A's will be specifically this this value that's going to be used as a return address. So there's like a thing called pattern. So you can like create a pattern string, right, of size 200, I guess, because the buffer is 100. So we can run it, give it the pattern string, and now we have a unique string of characters, and this this program will basically tell me at what offset it landed on. So I know specifically how many bytes I need to write up to in that buffer to reach the return address. So I can do pattern offset, pattern search, and it tells me that I need 112 bytes to reach the return address because that's EIP. And okay, so now I know that I need at least 112 bytes of padding, and the next 4 bytes will hit the return address. Any questions so far? Yep. Oh, this is GDB Peta. You can find it at. So let's see, where's that? Yeah, you can find it here. GitHub, Peta, and the installation's pretty quick. Okay. Any other questions? So you guys know how to get the length of the buffer now to hit up to the return address? Pattern string? But I mean, like, it should be the same because I already gave you the offset. It's 112 bytes. And the next 4 bytes will be the return address. So now the program spits back out to you the address of the buffer, right? So we just have to overwrite the return address with the address of that buffer. But this comes down to like the next thing, which is the architecture's endianness and how bytes are stored in memory. So like I'm running the x86 architecture, right? Intel, which is on most computers. And like that's going to be low endian. So the bytes are going to be reversed in byte order. So like, for example, like hex cafe babe is going to be, Oh man, you can't see that. Like whatever. So like Hex Cafe Babe in byte order, the BE is gonna be like first, and then like BA and FE and then CA. So like with each byte, they get placed in reverse order. Right? It's a bit tricky the first time you do it, but when you get up to there, just tell me. Anything else? Sure. All right, so this is the exploit itself. So I have the shell code here. This, you can grab the shell code off of Shellstorm. Shellstorm.com/shellcode. Right. So like, I have the shell code here, and then I have this CC byte, which is going to be padded by the length of the buffer, 112 minus the length of the shellcode. So that's going to pad up to the return address. And when I send it, I send all of that plus P30 plus like this is going to reverse the endian, put the buffer address in load endian form, and send that to overwrite return address, right? So when it returns, it's going to grab the return address that they sent us, and we're going to jump into our shell code, and that's going to execute the shell. Any questions on that? This is Pwn Tools, but I mean, I could change this to just Python sockets, I guess. Because it makes life a lot easier, to say the least. But yeah, like so, Pwn Tool does this thing where you have P32. That means like to pack this as a 32-bit integer. But Python has the same thing in struct. Which like essentially does the same thing, and that's like from Python. Yeah, I'll just come around and help you guys out.